Right now we're going to start off by talking about a falling object. Okay, so here we have an object. It's on the top of, say, a 30-meter cliff, and we're going to drop it. Okay, it has a mass of 1 kilogram, and what I'm going to ask us to do is actually find out what's going to happen to this object as it falls. Okay, so the first thing that we can think of is, well, in order for it to be falling, some force is going to have to cause that to happen, and the force that causes thing to fall downward would be gravity. Okay, in this case, the gravitational force is going to be equal to its mass times the strength of gravity, or 1 kilogram times 9.8 meters per second squared. Okay, giving us 9.8 newtons. Alright, and then so we remember back to some previous chapters where we talked about Newton's second law, which says that acceleration is equal to the net force divided by the mass. Okay, and if we plug the numbers in here, we can actually find out at what rate it's going to accelerate downward. Okay, or at what rate gravity is causing it to accelerate. So the net force would be the sum of the forces. In this case, we just have the 1. So we're going to put 9.8 newtons. We're divided by our mass of 1 kilogram and get 9.8 meters per second squared, which tells us that this object is going to accelerate downward at a rate of 9.8 meters per second squared. Okay. We know that it's going to fall 30 meters. We'll call that our displacement. Right? And then we can actually solve for how long that's going to take. Okay? The last piece of information that we're missing is that, as I said, we're dropping it, which means our initial velocity would be equal to 0 meters per second. Okay? As I'm writing these values, hopefully you're starting to think of kinematics, because that's the equations we use in situations like this, where we have multiple variables and we're solving for a missing one. Okay, well, the kinematics equation that has these 4 variables is this one right here. Okay, so delta x equals v naught t plus 1/2 at squared. Okay, we're going to say that the direction down, we'll call that positive. And so our displacement is 30 meters. Okay, our initial velocity is 0. Our acceleration is 9.8. And then we're solving for t. Okay, so we get 30 meters equals 1/2 times 9.8 is 4.9 meters per second squared times t squared. To solve this, we divide over the 4.9. And we're going to get that t squared is equal to about 6.12. These are meters per second squared. The meters cancel out, and since we're dividing by 1/second squared, they actually go to the top. Okay, finally we'll take the square root of both sides. Okay, and we should end up with about 2.47 or 2.5 seconds. So what that means is, if we were to drop a 1 kilogram object off of a 30-meter cliff, it would actually take about 2.5 seconds for that object to hit the ground. Before we move on, I just want to point out, since we calculate the weight of something by multiplying its mass times gravity, and when we find acceleration, we divide by the mass. For objects in free fall, in which gravity is the only force acting on them, their rate of fall is always going to be equal to g, which is about 9.8 meters per second squared. Occasionally we use 10, sometimes we'll use 9.8. Okay, and this will be the case for all falling objects. Okay, this time we have an object with a mass of, say, 2 kilograms, and we're going to drop it from rest, and it's going to fall 100 meters. Okay? As we drop this object, since we're dropping it, we know that its initial velocity is 0 meters per second. We know that it has a displacement, we'll say down is positive. So we have a displacement of 100 meters because that's how far it's going to fall. And we know since it's in free fall, the acceleration is 9.8 meters per second squared. Now I want you to go ahead and solve for how long it's going to take. You should have submitted your answer. We start with a displacement. We're going to use this equation again. We're going to put in 100 for displacement, 0 for initial velocity, 1/2, and then 9.8 for acceleration. This goes to 0. So 0 times 2 is 0. 1/2 times 9.8 is 4.9. Okay, 100 meters equals 4.9 meters per second squared 2 squared. Divide it over, take the square root, we get 4.5 seconds. Before we move on, I do want to sketch some graphs. Okay, if we were to graph the acceleration of this object, it would be 9.8 the entire time meters per second squared. If we were to graph the velocity, okay, it starts from initial velocity of 0. That velocity increases as it falls. Okay, and then finally, our displacement, our position, okay, we're going to start from, we're going to say we send down as positive, so we start from a position of 0 and get further away from it rapidly as our velocity increases. Okay, so that would be acceleration, velocity, and position graphs here.